right, here we are with Alon Muroch, SSV Labs founder and contributor to the SSV Network. Alon, it's so great to have you on the Defiant. Welcome.
Thank you for having me. It's great to be here.
Awesome. So SSV is really innovating in Ethereum staking and restaking. This is one of the biggest industries and sectors within Ethereum and DeFi as a whole. So really interested to hear more about how SSV Network works. So maybe we can just start from the very basics, and if you can provide an overview of what SSV is and what purpose does it have in the Ethereum ecosystem.
Yeah, sure. So we've been working on SSV for quite a while now. We started with what is called Distributed Validators Technology, which is kind of the basic idea is to have take an Ethereum validator and split it up between different entities. And those entities can coordinate and run that validator together as a building block. Now, if you do that at scale, then you can really decentralize and change the infrastructure staking is operated on. And so that was really what SSV started with. And we've been working on it for quite a while. And we actually launched fully permissionlessly to mainnet at the beginning of 2024 and had pretty tremendous growth throughout 2024. Today, we just crossed 2 million ETH at stake. So we're the fourth largest staking protocol on Ethereum, managing roughly 5.3 or 2% of all of the staked ETH, which is pretty significant. And so really that's what the gist of SSV is all about and what we're doing.
And congrats on all the success in just 1 year after mainnet. So what motivated you to start SSV? If you can just provide, I'd love to kind of learn more about yourself, your background, and what led you to creating SSV.
Right. So I've been in the industry for quite a while, around 10 years now, and Ethereum was always my main focus. And in just before staking in Ethereum really became a reality, we understood this is something big, which is something that we can really tap into. And so we started working because, truly at the bottom of our hearts, we really are Ethereans and we love this ecosystem and we wanted to contribute, and decentralization was always a big part. And so the idea that we can take this fundamental building block on Ethereum and make it better was pretty interesting. And so really that was the catalyzer behind SSV. We've actually joined hands in the early days with the Ethereum Foundation to kind of POC the technology, DVT technology, and ever since then we kind of building this pretty big ecosystem where I think the idea is to provide infrastructure for the utilization of Ethereum validators. And that encompasses a lot of different things. It's from staking, but it can actually do much more. And we have pretty significant plans going forward with that direction. But I think that as a component of infrastructure, I think enabling validators on Ethereum to do staking, but then do more than just staking, might it be DVT clusters or might it be other things? I think that's pretty exciting, and the economics behind it are pretty interesting.
Awesome. Okay, so I'd love to dive a bit deeper in all the different parts of SSV. So you mentioned things like DVT and also secret shared validator technology. Things that maybe just like the average Ethereum user or staker and validator might not be familiar with. So yeah, I'd love to kind of get a better sense of like what these different terms mean and how SSV works in more detail.
Sure. So SSV has, we've developed our own node, basically a piece of software where anyone who wants to participate in SSV runs. And on the other hand, you have stakers coming in and they're able to choose different operators that run this piece of software to actually run their validators. Now you can run one validator and you can run thousands of them. But you simply choose the operators you want to work with. It can be your own operators. It can be third-party operators, trusted operators, permissionless operators. We have a bunch of different ways to go about doing that. And so, in order to start running an Ethereum validator on SSV, you simply do an Ethereum transaction. It's that simple, 12 seconds, and you can start running a validator on SSV. And so, in that regard, it's super, super simple.
What are the benefits of running a validator in SSV?
Right. So, one of the main things, so I will split that answer into two. So one of the main things is really decentralization. By using a better infrastructure to run your validators, you can actually have better infrastructure in terms of security, in terms of decentralization, fault tolerance, slashing prevention, all of those things that you want as infrastructure. And so that's kind of part one. Part two, and that's something we've been working on for quite a while now. We actually have this vision in mind called actually SSV 2.0, which is the idea that you can take those validators that you run in a decentralized way on SSV, and you can reutilize them to actually secure other protocols. And by doing that, you can actually get extra rewards. So if you think about it, really SSV is two things. One is infrastructure for running staking. But on the other hand, it's also a marketplace, an ecosystem for earning extra rewards for your validator. And so, as a summary, like what is SSV 2.0? SSV 2.0 is this free egalitarian marketplace where, on the one hand, developers can come and build applications that require security. It can be oracles, it can be bridges, call processors, data availability, whatever, base sequencers, pre-confirmations, and so on. And on the other hand, you'll have those validators themselves, the stakers, that can actually tap into that marketplace and not only run on a more decentralized infrastructure, but it can actually earn extra rewards by doing so. So everyone is it's a win-win situation. Developers can come, bootstrap using the best validator set in the world, right? Ethereum is by far the best validator set in the world. And on the other hand, stakers can come and actually earn extra rewards. So that's really, I think, what SSV is and where it's going with this vision of SSV 2.0.
It reminds me a bit of on the EigenLayer model, where they are also providing the ability to for stakers to use their staked ETH to secure other networks. So how is SSV different from EigenLayer?
So I think restaking in general is a very, very interesting concept. I think what's missing, there's a few things missing with restaking. So point number one I will make is that restaking has some very non-desirable cascading effects on Ethereum. So because restaking is using existing validators and they basically lock those validators into the protocol, and then if something happens, they slash them, it creates this cascading risk not only on the stakers, but also on Ethereum as a whole. And that cascading risk is pretty bad because nobody really wants that, right? It's you want to isolate risk so you can manage it, not have it cascading on a whole system. So that's really point number one, I think, that's missing. The point number two is that people don't realize, but because they're using only slashable capital assets, restaking is actually a zero-sum game. If you take 100 ETH and you allocate that in one of the restaking platforms, obviously to maximize your rewards, what happens if another really, really great service comes along and you want to provide security for it as well? Because you're allocated 100 ETH already, the only way you can do that is either bring additional capital from home, which is not something people usually do, or deallocate from one service and move it to another service. So it's a kind of a zero-sum game, which is really bad. We identified those two challenges, and so there are two really main differences between what we're doing, which is called based applications, because they're based on the Ethereum validators, and restaking. One point of difference is that we are actually using the validator as an entity, not the capital behind the validator. And so by using that, we're gaining two things. One is that validator is never slashable. And so there's no cascading risk on Ethereum, on any other L1. Also, the costs are significantly lower because validators, again, are not capital. So the risk parameters are completely different. Developers that do require slashing capital, they can have that as dedicated slashing capital, but for the most part, what they want is they want Sybil resistance and they want really high TVL securing their protocols. And so that's really point of differentiation number one. We're actually using the validation key of the validator, which is a very different approach and has a lot of benefits. The other approach is that instead of kind of the traditional risk-taking model we have today, which is kind of a zero-sum game, we're actually developing a very different approach. We call it risk-expressive model, which basically looks at slashing as a risk, right? Because that's what it is ultimately. We've built this mathematical model which enables you to create more and more and more risk as somebody who wants that risk. And for the services to say, okay, I'm fine with this amount of risk or that amount of risk, and adjust how much weight voting power they give you. And so instead of having this really, really, strict rule where, if you allocate your assets, you cannot allocate anything else. And if a great service comes along, you're basically, you can't really participate unless you deallocate and move capital from one service to another. We took a different approach, which enables you to do both, because you can allocate and continue allocating. You can increase your risk, and services can adjust to that risk. And so the end result is, on the one hand, a much safer infrastructure, which doesn't have cascading risk and it's cheaper. And on the other hand, it's much easier to bootstrap on, because you can much easily convince stakers to join your service, because they don't need to deallocate from another service. So instead of talking about a zero-sum game, based applications on SSV 2.0 are really infinite sum games. And so I think those two approaches really fundamentally change the economics and viability of this model, and we call it based applications. There's another point that we've researched and implemented, which is, if you're using Ethereum validators to secure other protocols, that's amazing because Ethereum is really good, right? But why just Ethereum? Why can't you use Solana validators? Why can't you use Bitcoin? Why can't you use Cosmos validators, right? And so one of the main things we are doing is actually saying we want those validators to be able to secure other services as well, because they have a lot of value. If you can combine a bunch of different validators from a bunch of different L1s, the sum of the security you can provide is much greater than the pieces of those, right? And so we've actually going to develop and already started developing a based application blockchain, a dedicated blockchain to coordinate, on the one hand, based applications, on the other hand, multiple L1 validators, Ethereum, Solana, Bitcoin, Cosmos, and others, to actually have that coordination layer, which is credibly neutral, so that multiple L1 validators, not just Ethereum, can participate, secure other protocols. So really, those are the three main changes. One, we're using the validation keys of the validator. There's no cascading risk. It's much cheaper. The other part is, instead of doing a zero-sum game model, we're invented this risk-expressive model, which is infinitely scalable and makes it very easy to bootstrap. And thirdly, we're going beyond just Ethereum. We strongly believe that diversity of validators can be a really good thing for services providing that want security and want bootstrap. So that's really the main differences between risk-taking as today and based applications, which is what we're building on SSV 2.0.
Super interesting, but I still don't quite understand how you can use just validator keys and not the capital itself. From what I understand, proof of stake works on having capital at stake, and that's the way you secure the network. So how can you secure a network without capital?
So this is a really good point. My point is that it's not about not using capital. The point is about how much capital do you need. And so with the risk-taking model, 100% of your security is capital, right? You put in 100 ETH, that's the amount of security you can provide. But if we look at other proof-of-stake systems, Ethereum, for example, most cases, you don't really have 100% slashable capital out of your position. So if I take an Ethereum validator today, one validator and slash it, right? I actually get slashed for 1 ETH. So 1 ETH out of 32, right? That's 3 point something percent. That's everything I get slashed on. Actually, post Spectra, that amount of slashing will go down. So my point is, it's not about not using capital. We are using capital. The point is, how much capital do you need? And so what we're saying is that you don't need 100% of your position to be in capital. You can leverage a different asset class, which is your validation key. You can leverage that together with some slashable capital, not all of it, just some of that, and actually get much more security out of that for the same cost. And so it's really not about this or that. It's about what is the best way to get the most security for a given cost, right? So if I'm a protocol and I want to bootstrap and I have, let's say, $100, how much security can I get in $100? Well, from our simulations and what we've researched for the past 6 months, you can actually get almost 200% more security in our method in based applications than in restaking, because the cost of capital is much higher than the cost of the validation key, right? And so that's really the difference.
Super interesting. Okay, so what you're doing is you're taking the initial stake capital and kind of like splitting it into many different networks?
So it's actually already split. When you create an Ethereum validator, that Ethereum validator has two keys. One key is the withdrawal key, right? That's where once you exit your validator, that's where all of the assets go to, right? And that's what restaking is using. So they're actually using your capital. The other key is the validation key. The validation key is the one that actually signs in the behalf of the validator. That's actually the operational key of the validator, if you will. And so we're actually using that. And the reason why we use that is because we already are using it. In SSV today, the 2 million ETH at stake are staked on SSV through the validation key. The withdrawal key is not part of SSV, actually. And so we already have that separation. And so what we're saying is that everyone is looking at the withdrawal key as the asset. We're saying, no, there's another type of asset you have in your validator, and it's worth a lot of money, which is the validation key, because that's the actual entity of the validator, right? It has a lot of interesting properties.
Really novel approach. And so this based applications, where should they be built? Like, do they need to be built specifically on the SSV network, or can any Ethereum application be secured by SSV network?
So I think that any application that requires out of Ethereum security, right? If you're building a smart contract, that smart contract is secured by Ethereum. But if that smart contract has, for example, an oracle, right? That oracle is not secured by Ethereum. And so those are the type of applications that fully get the value out of something like based apps, right? And again, going back to the concept, based applications really the name suggests that they are based on Ethereum validators. That's kind of the concept there. And so it's services like oracles and bridges and co-processors and data availability and base sequencers and AI and all of those types of things, which are not secured by Ethereum, but serving Ethereum and other blockchains. And so in order to have and they're critical, right? They play a major role in those ecosystems, and so they need really good security. In terms of what developers should be doing, we're actually building a very, very minimal layer of coordination. So developers don't really need to do a lot in order to integrate. That's one of the key things we think is important. We want to be as minimal as possible. And so we're working with a lot of other developers and a lot of other people in the restaking world and outside the restaking world to really introduce this novel approach to get that developed. And so we foresee that the long tail of those types of services would really enjoy an easy integration and an easy approach for bootstrapping to finding operators.
Okay, so you're trying to attract applications who serve different Ethereum use cases, but are not but whose smart contracts are not secured by Ethereum?
So their smart contracts could be secured by Ethereum, but a part or all of their service is not on chain, basically. So an Oracle, for example, serves Ethereum, right? But it's not, it's an off-chain service. So all of those types of off-chain services, yeah.
Okay, so those types of applications from on one hand, and then on the other hand, you're also looking for stakers who want to get a greater return from their stake capital.
Yeah, we already have those stakers. SSV has been operating for quite a while, and so we have those stakers. And I think that that's part of the interesting approach we have with SSV 2.0 is really the idea that we already have the supply of security, right? And so we want to create the demand for it as well. And so, you know, even today, a service can come and tap into almost 2 million ETH worth of security, which is more than most 99.9% of services need anyway.
And so how were you able to attract all of that stake capital without kind of the other part of the equation?
So we've been very aggressive on DVT as a concept. We strongly believe in decentralization. We strongly believe in contributing to the validator set of Ethereum. And so not only did we develop the technology, kind of from the first steps we made on mainnet, the SSV DAO has committed for accelerating adoption of SSV. And so the SSV DAO created an actual dedicated incentivized mainnet program where every validator that comes to SSV gets extra rewards in SSV tokens. So that really played a major role in growth. And it also gave us the idea that those validators really are really want that extra yield. And so creating a marketplace of services that can now offer that to them is quite interesting and quite powerful.
You mentioned the SSV token. What role and utility does the SSV token have in the ecosystem?
So actually, the SSV economics are going to be transformed with SSV 2.0. So currently, every validator on SSV pays a fee, right? And that fee is network fee. That network fee is paid with SSV tokens. Moving to SSV 2.0, not only that they will be paying network fee for validators, every participation in services, securing services, will pay extra fee. And also because we're building this based applications blockchain, every transaction fee on that blockchain will also be in SSV. So it's basically, we're moving from one dimension to three-dimensional fee structure in SSV. Also, in parallel to that, the SSV chain will be actually utilizing the concept of based applications. So validators on SSV will be securing the SSV chain itself, right? Which is pretty cool. And the slashable asset or the asset at stake will be SSV as well. So we're adding SSV staking to SSV 2.0. And a third part of that will actually be some SSV burning. So you'll have moving from one dimension to three-dimensional fee. Some of that fee will be burned, and a lot of SSV will be staked in order to secure the SSV chain, the based applications chain. So the SSV economics for the token are upgraded quite significantly in SSV 2.0.
So when is SSV 2.0 going to be live, or like what milestones and timelines are we looking at going forward?
By the time this conversation will be online, we'll already be hopefully post the announcement for SSV 2.0. We're going to release the white paper detailing everything I've talked about. In March, so just in two months, we'll have a public testnet. And then right after, we'll have the first V0 mainnet for based applications. Towards Q3, we'll actually have the genesis for the chain itself as well. So we have some major releases this year. As
we wrap up, I just want to ask a unrelated question to SSV, which is on Ethereum itself. Like right now, we're seeing a bit of commotion or backlash within the Ethereum ecosystem to how Ethereum has been run by the foundation, and there's some calls for leadership change. As someone who's been so Ethereum aligned and building towards Ethereum security, how do all these questions to Ethereum leadership affect you and your vision, if at all?
So I see it as one of the greatest exercises in decentralized governance ever. Ethereum doesn't have a traditional DAO governance, right? It's not. There's no voting with Ethereum unless you're a validator. There's no really voting on proposals, but there is this entity called the Ethereum Foundation, which is basically is subsidized by the Ethereum greater ecosystem, right? The interesting part here is that there's a million different people talking about Ethereum in different ways. Everyone wants different things. And so I see it as a really interesting exercise in governance. And I really am excited about to see how will this resolve, right? I mean, will Ethereum and Ethereum Foundation become stronger afterwards or not? I think this is first-class exercise in governance, and I think can really only happen in Ethereum. I can't think of any other project at this scale that undergoes such scrutiny like Ethereum and has those types of challenges. And so I see it as a very, very positive exercise.
So it's not undermining your confidence in building on Ethereum at all?
Currently, no, not at all. I mean, again, depends on how this will resolve. But I think that if this resolves in the way I think it's going to be resolved, which is a change for the good, I think Ethereum will come out much stronger than it used to be.
Great. Okay, and then to wrap up, what should people who want to get involved with SSV Network do, or where to start for people, for
Right.
applications who want to secure their networks?
So definitely go to ssv.network, chat with us. We are very friendly and we love developers. We've been a developer-focused protocol from day one, and so this is not new for us at all. And we're definitely welcome any developer that wants to build a meaningful service that needs security, needs to bootstrap its security. And we strongly believe we have the right tools for them. And so, yeah, definitely reach out.
Amazing. Alon, thank you so much for your time. Again, congrats on all your success, and looking forward and excited to SSV 2.0.
Thank you very much.